Yeah, let me just share my screen. Okay, so today we have two practicals, two packet tracer activity files that we're going to look at. Right, so you can see here, the first one is investigating three types of traffic within a network, which is these are the network layer level. Okay, so we're going to look at unicast, broadcast, and multicast traffic for the first packet tracer. Right, and although we haven't covered the IP version 6 addressing, in theory, this is where we are going to configure IP version 6 address, okay, on our host and interface. So we've done this for IP version 4. So then we look at how we're going to configure IP version 6. Okay, the main difference basically is that the format of IP version 6 address compared to IP version 4 address is different lah. So that's our second packet trace activity. All right. So let's go to right. Hold on, this one. This right. Let's go to this. Okay. So I hope you guys will follow along. 7138 packet tracer investigate unicast, broadcast, and multicast traffic. Right. So before we look at the activity file, let's look at the topology first. So here we're having three PCs very similar to previous, and then we get the three PCs connected to switch, forming a local area network, connected to the router, and then the router connected to router 1 connected to router 2 and 3, right? So let's have a look at the activity file. All right, so our objective in this activity file is to part 1, to generate unicast traffic. We have a look at it. We probably will be using the simulation tab, yeah. And then after that, we're going to look at broadcast traffic. And third part, we get to look at multicast traffic, right? So we're going to look at their behavior, right? So one of the things we already, let's say, we already know in our lecture. For example, let's take broadcast. Broadcast, we know from theory that it's not going to be forwarded by a router. So later when we issue broadcast, we'll actually see whether it's stopped by the router. For example, these are the behavior of broadcast traffic. Okay, so that's one of the example that we're going to observe, right? So majority of traffic in a network is basically unicast. Okay, so when you when you send a ping or ICMP echo request to a remote router, the source address in the IP packet header is the IP address of the sending PC, and destination IP address, of course, is the IP address of the interface on that remote router. Right? So the packet is sent only to the intended destination. Okay, so we use the ping command, or we can use the add complex PDU feature of packet tracer, where you can directly ping broadcast address to view broadcast traffic. So, well, either you use the ping command and issue an IP address that is broadcast. Okay, we already know broadcast in a network that is not subnetted. Okay, the last address, right? That means it's the network address dot 255. That's clear. Or you can use the complex PDU feature of the packet tracer to create the broadcast address. So using ping, right? Then you can use the simulator to view how the ping message is being forwarded. For multicast traffic, we'll be using the EIGRP traffic. This is the protocol that I was mentioning about, where this protocol is being used by the routers. Okay, so it's used to exchange routing information between routers. right? So routers will be using EIGRP to send packets to multicast address 224.0.0.10. And this represents the group of EIGRP routers that is part of this multicast group. Although these packets are received by other devices, they are dropped at the network layer, layer 3, by all devices except these routers. Okay, no other processing required. Means they just look at the destination IP address. When they see that it's a multicast address, because they're not member of the multicast address, they will drop it, except for routers. All right. So again, I will not go in detail step by step, because I do want you guys to also do on your own, especially the part where you have to answer questions. Means you will observe. Once you do it, you observe, okay, and based on your observation, try to answer the questions. Okay. Right. So let's look at part one: generate unicast traffic. We're going to use ping. Right. So you're going to go and click PC1 and click the stop to command prompt and type ping 10032. So let's just put it to the side and okay, put it this way, right? When you enter ping 10032, okay, so I think by now we all know how to do this already. Click PC1, just gonna drag it here to desktop, command prompt, and ping the specified um, address, IP address. So basically, we have right now we have no idea which one is it, right? Never mind. Okay, because just by looking at topology, because the labels are not being provided. Okay, so you have to basically investigate. Okay, investigate your devices to find out. Okay, uh, which of the PCs have this 10032, or which of these router interfaces? Okay, there are many. Right? And you can see the routers have this interface. For router one, this interfaces. Router two has this interface. Router three has this interface. And in addition, we also have two interfaces each for each of the PC hosts. So never mind. Later on, we'll find out. First, we just do it first. Then we notice that the ping is successful. There is a echo reply. Okay. Right? So you can see there ping should succeed. Now enter simulation mode by pressing the simulation tab down here. Click that to enter the simulation mode. Edit filters and check only two protocols. That means in simulation mode you will only capture two types of events, which is the ping protocol, ICMP, and the EIGRP, which is the multicast. Right? And then click PC1 and enter that command, same command again. Right? So we know this is unicast because this is a unicast address. Right? And then because you're in simulation mode, you can actually see the message passing through each segment of the network. So the PDU starts off at PC1 because you initiate the ping from PC1, right? So you can see that it's an equal request, okay? And because it's given already here, so you don't have to guess. 10032 is actually the interface on router 3, right? So and then to proceed, you click capture forward, okay? One at a time to see the message being forwarded, right? And you can see that it will be sent to router 3, and you keep on pressing the capture forward button. The echo reply is sent back to PC1. Then you stop when the first echo reply reaches PC1. Okay, so from there, you notice, right? You notice the ping packet moving, right? So which devices did the packet travel through with the unicast transmission? So from PC1, okay, so it move on. So which device does it pass through in order um, to go all the way to the target interface and come back to PC1, right? So please answer that. Okay. And in the simulation panel event list section, the last column contains a colored box that provides access to detailed information about an event. Click the colored box in the last column for the first event. Okay, last column for the last event. So that means when the echo reply reaches PC1. Okay, the PDU information windows open. What layer does this transmission start at and why? So you you can actually click on it. You can see which layer. Just examine that layer. Okay, and notice that both source and destination IP addresses are unicast address that refers to PC1 and the serial interface on router 3. What two changes take place at layer 3 when the packet arrives at router 3? Okay, so you already noticed the layer 3 packet information before you reach router 3. Okay, once you reach router 3, and when it's going to outbound of router 3, do you notice any difference within the header? Note down what are the changes. Okay, note down what you see as the changes. Okay, right? Any questions for that? Once you did all these things, right? Click reset simulation. Just go here. Reset simulation is here. Okay, so that prepares you for part 2. Right, it will clear all captured PDUs. Right, so that means you finish with the unicast. Okay, unicast observation. Now we go to broadcast. Okay, so we now investigate the second type, which is the broadcast traffic. Recall that unicast is one-to-one, broadcast is one-to-all, multicast is one-to-some. Okay, and the sum means the few devices or hosts that is actually part of the multicast group. Okay, right. So for generate broadcast traffic, you need to use the add complex PDU, which is that icon up here. This one is simple. This one is complex. Basically, you're going to click on that to initiate the broadcast. Right? Okay. All right. So when you click that, okay, and you see that your cursor will change to envelope with a plus sign. Okay, so we want the PDU to start from PC1. So you after it changes to envelope, the loop envelope with a plus sign, you click on PC1 because we want PC1 to be the source, right? And then you can see that a window will open up. For example, like this. Click. This window will open up. Right? Okay. So all you need to do is destination IP address, key in this, which is the broadcast address, key in the sequence number. Sorry, destination IP address is not the source. Sorry, destination source. Leave it alone. Destination, sequence number, and one shot, and put 0 seconds. Okay, that's the setting you need to put for this complex PDU. And then when you've done that, because we're creating this so that we can control what is our destination IP address. So leave that as ping. Right? You can see that select application is ping. Right? And check. Click that drop down menu or drop down option there, and answer this question. What are at least 3 other applications available to use here? Apart from ping, what else can you choose? Take note and write your answer in a separate Word document as before, and then create PDU, right? Then that broadcast packet will appear in this simulation panel here. Okay, this area. Okay, simulation panel event list, right? It also appears in the PDU list window, right? And after that, okay, you will click capture forward, which is this button here, twice. Okay, the packet will be sent to the switch and then will be broadcasted to PC2, PC3, and router 1. Look back at the topology, it will send to this, and router 1. Just close this first. It's bigger. All right. So you will see that it will travel to here. The first click, second click, of course, it will be traveling to here, and to router 1. Then examine the layer 3 information for all of the events. So at here, okay, the event list, check it, okay, examine it. Notice the destination IP address is what you have entered earlier on, 255.255.255.255. Okay, that is the IP broadcast address. Okay, when you type in inside the complex PDU creation. Okay, so analyze the OSI model information when you click the PDU here, right? Okay, at this pre-location. What changes occur in the layer 3 information of the outbound layers column at all three? Okay, router 1, PC2, and PC3. Right? The outbound means because the PDU will arrive here, right? After the second click. So the tab, click the outbound one. For the outbound, take note the layer 3 information, which actually means the layer 3 header. See what happens there. Okay, what's the difference between the previous one? Okay, when you first send it out, and when at the PC2, let's say PC2, the inbound compared to the outbound, right? You check what changes occur in the layer 3. Take down your answer, write down your answer. Next, click capture forward again. Does the broadcast PDU ever being forwarded beyond router 1? Does it travel to router 2, router 3? Okay, and answer that question, and then answer the why question, right? Okay, so after you finish answering that, delete your test packet by clicking delete at the scenario here, right? And again, reset simulation. Okay, set simulation, and then it will clear up here. The complex packet also will be deleted here. If you delete here, 0, right? Okay, so then you should be done with part 2. Okay, and then for part 3, you're investigating multicast traffic. Okay, so we're going to the third one, which is where one to some. Okay, some host or some interface. Right. So we start with examining the traffic generated by routing protocols. So here the multicast group is basically the routers. Okay, and the message being passed between these multicast groups are the routing protocol, which is EIGRP. Okay, so there's nothing to do here. Just click capture forward. EIGRP packets at router 1 is waiting to be multicast out of each interface. Why? Because why you don't have to do anything? Because this is actually automatic. If the router is set to share routing protocols, the router will do that from time to time. Okay, that means you don't have to initiate the sharing. This protocol is automatically done by the routers that has been configured to do that. In this way, we hope that the router can self-configure itself to inform each other about the path. The path further beyond router one. The path over here can come down, can come up, can something wrong, can whatever. So that means the router closest to the network that has maybe it's broke down or whatever, the configuration change. Therefore, what do you call this? The path may change already. So router 2, of course, will know about it because it's directly connected to the changes. Yeah. So router 2 will inform router 1, for example, and router 1 will reconfigure its routing table, so it will know about this in automatically. Okay, and also the vice versa. If the network here changes, if you add another network here, for example, the router will know there's another network. The router will share that information with the other routers in the same multicast group. And this is the point of ERGRP, for them to be able to update, for the routers to be able to update their routing table, and of course automatically. Okay, so it doesn't have to wait for administrator to come in and issue command to say, okay, now update, right? So back to our exercise. Okay, you click capture forward. The ERGRP packets at router 1 is waiting to be multicast out of each of its interface. Okay, at each of this interface. Examine the contents of these packets by opening the PDU information window and click capture forward again. Okay, next capture forward. The packets are sent to 2 other routers. It means it goes out here, it goes out here, it goes out here. Okay, it goes to the switch, it goes to the router 2 and router 3. Okay, and the switch has no idea about layer 3, so it sees the incoming packet frame. So it sees incoming frame, it will forward out. Okay, forward out to the PCs. And then you click capture forward until you see a GRP packet arrive at PCs. Now at the PCs, you answer this question. You check the PDUs. What do the host do with the packets? Examine layer 3 and layer 4 information for all ERGRP events. Now layer 4, okay, we haven't touched on it, but have a look at it. Okay, layer 4 is the transport layer above layer 3. Layer 3 is network layer. Layer 4 is transport layer. Examine it means take note inside the PDU header. Okay, right. For layer 3, you do have the logical address, the IP address. So what is the destination address of each of the packets? Okay, right. Next, click one of the packets delivered to one of the PCs. What happens to those packets? Based on the traffic generated by the 3 types of IP packets, what are the major differences in delivery? So these 3 types are the unicast, broadcast. This last question is about asking you the 3 types is unicast, broadcast, and multicast. So based on the traffic generated by the 3 types of IP packets, what are the major differences in delivery? So you already take note, right? From unicast to broadcast to multicast. Okay, so comment on what are the differences you can see. Right? So basically, when you see the packets traveling for unicast, observe, take note how it travels. For broadcast, observe, also take note, and multicast, take note. Okay. Oh, one thing I wanted to say is the theory part. Try to reconcile with what you're seeing. Unicast 1 to 1, broadcast 1 to 0. Does the delivery uh, uh, match what the theory said? And multicast, how does it work? From here, when you try the multicast exercise part 3, you will see how it's actually work. As it means one packet just go to the multicast group, or the packet go to everywhere, and only the multicast group will process it. Take note of this, observe the behavior, and write out your conclusion. All right. Any question? Any question?
No.
All right.
How
So
do you delete the?
how do you
No,
what?
no, no. I'm following the steps. How do
How do
you
you
in the part 2 last step? How do you delete?
part two? Okay,
Part
hang
two,
on. Part two.
delete the
Last.
test packet.
Oh, yeah. Go to here. You can see the scenarios below the scenarios. This is scenario 0. Once you create, you can actually see here. So just click the delete here. You delete
Oh,
the one that you created.
oh, okay. Thank you.
Okay, down here. Right. Any other question?
No.
All right. So can I let you guys do for half hour before we go to the next one?
Oh, okay.
Yeah. You try to do it,
Okay.
and then I'll check back with you occasionally. If you have any question, I'm monitoring, so ask me directly. And then later at now is 10, 9:30, 10:30, 10:30, 10:30, we start the other one. Okay, the configuring the IP address, but you do first. See whether if you cannot finish, let you some more time to try and do. If you have any question about your, because here the observation, if you want to make sure whether uh, your observation actually is correct or not, you can also ask. But the important thing is you try it out and see, observe the behavior of the packet. Right, these things you cannot see in real life. You can see the effect of it, which one receive which one, but it's very difficult. Okay. Here what we want to do is we want to able to see the packet traveling, and then what you're supposed to do is try to match your understanding of the unicast, broadcast, and multicast theory, yeah, with what you are seeing inside the packet tracer, how actually it's working. Right. All right, so I'll let you guys do, and then any question, let me know. Try to answer. Huh? Okay. So I just did a unicast, so you can see that it's traveling all the way here. What I want you guys to do is follow the direction and click on the video requested and write your observation. Write your answer for the question. Right, for multicast. Okay, remember for part 1 to part 2, we set simulation, and then clear. Go to here, the create the what, and then click on. You see the icon change. Go to PC1 and ping. is correct. Destination put 255, 255, oops, 255, 255. I leave source IP address, my sequence number, and this one 0, and create PGU. And immediately you can see that there's that. Okay. So further, if you actually mind it, you cannot see, you drag a little bit more. Okay, you can see the CMP packet. Okay, so there's no in because we are generating it, so it's out. Yeah. So take note of the layer 1, 2, 3, but especially layer 3, and take note the destination because we created with a broadcast destination address. Okay, right. So again, broadcast. What you do is simply follow where it goes. You can see the switch because it's a broadcast. Just if you're looking at it also, when you're looking at when you're looking at that, take note also that it mirrors the layer 2. Can you guys see that? When you're doing this is how you observe. Layer 3, we know we put destination IP as broadcast, but we didn't do anything about the frame, right? But the frame at the data link layer, because they're next to each other, the layer 2 also put the destination MAC address as broadcast address. Can you see that? FFFFF. So that's why the switch forward the frame in point of view of the switch to all ports, right? So that's why it goes to PC2, PC3, and router. So it's actually following following the network layer. Network layer, you say you want to broadcast. So the frame also, in order to transport it, so that the switch know how to, because the switch cannot see your IP broadcast message. Okay, so the switch will help out the layer 3 by also putting in the MAC address as broadcast. You notice that? Okay, right. Okay, so we reach here and then you follow the direction. Okay, and after that you will answer, your answer. Okay, and the one that you want to delete, just now you ask, is this one, the packet created in the scenario 0. So if you want to move from this to the multicast, you just delete this. Okay, and then the next is just you don't need to do anything for the multicast. Click. You can see it's actually coming out from router 3, the ERGRP. You can see that. Okay. And then router 1 also sending to router 2. Okay. And then router 1 also sending to the other interface, the switch. Okay. And from the switch, it's actually when it's being sent, when it's being sent to the switch, I want you to, from router 1, I want to check how come the switch sends to all. Check because switch doesn't look at the upper layer, network layer, it's just look at the frame. Okay, so EIGRP packet that goes to the switch, look at the MAC address. All right, is your suspicion about it because it's being sent to all ports? Is it broadcast? You check. And as it goes to PC1, what does it mean when it's XXXXX there? Right? Right, huh? Means router 2's turn, and router 1 also relate to router 3. Okay, it's done. Okay, this is the multicast. So multicast means what? The packets are what? Take note about the tick and the cross, right? And try to answer the questions. Okay. Hello, everyone. How's
Hi,
it going?
I think I done.
You done already, yeah? So answer, oh, okay,
Uh,
you,
there's some like how like why the where
ah, yes.
where the question again?
Which question you're doubtful?
Oh, like when why when the tree pack why the tree packet doesn't go to router? No, I mean
Which one? The unicast, broadcast, or multicast?
the
Which
broadcast.
broadcast, yeah? And the question is the F, is it the F? Does the broadcast video ever forward on to router 2 or 3?
Uh,
Why?
yeah, I don't know why I
Oh, okay. So we already covered this in lecture. Maybe you will just uh miss out the. I think we discussed already. Now the inside inside the LAN broadcast can happen, right? Broadcast can happen within the LAN. Okay, so routers are internet device that connect networks. So router is the one that is not going to forward. Router definitely will not forward any broadcast message because if you think about it, if the router allow broadcast message to go outside of a network, then potentially it can go everywhere on the internet.
oh okay okay.
Hmm. Yeah, we discussed before, right?
Okay.
Now you remember.
All right.
Yeah,
Yeah. Now I
yeah,
understand.
yeah. Okay. Any other question? Not sure, something like that. Farah, Noel, you just managed to complete. Any questions or any doubts on any of the question? Maybe not too sure about your answer.
No.
The
No, huh?
last question. Uh,
Based on
the
the traffic generated by the three types of IP packets, what are the major differences in delivery? Okay, so uh, actually we tried it already. You saw it already. So it's just to solidify what we're thinking. Yeah. So unicast packet, okay, it moves from the source to the destination. The destination being the router trees interface. 10, I think is it 10.10.03 or something like that. 10.032, right? So we saw that the message just move directly. It doesn't go anywhere else. It's just being forwarded directly to router 3 interface. Okay, so that's unicast. That means when we think about unicast um, traffic or communication, definitely from source destination. It doesn't go anywhere.
only one direction to
Yeah. Yes.
one place only. Oh,
Yeah. One to one lah. Huh? And then when we look at the broadcast, okay, the broadcast it, uh, it gets everywhere in the network, in the LAN, in the local area network, except outside of the network. So it gets blocked by the router, but within the network, it gets sent to all hosts. And the reason being, if you take notice just now, I highlighted something is even though you only specify network layer destination address as the broadcast address, the data link layer also to help out the switch, okay, also provide broadcast address for the MAC address destination address. You can see that it's FFFFF. So it mirrors what is going on in network layer, right? So we know if we broadcast in the LAN, the not only the destination IP address is broadcast, but the destination MAC address also becomes broadcast, right? And and then when the packets reach the host within the LAN, the broadcast packets, right? What happens is when it's outbound, take note that the destination now changes to the source. Okay, source IP address. That means PC1's IP address. So now it becomes the reply. After broadcast, we know broadcast, okay, goes to all the hosts, and then the host will reply because it's a ping, and the reply is become unicast. All right. This is if there is if it's a ping, if it's a ping, because it could be other packets. It's just that for this ping we put broadcast. So that means we are pinging to all hosts. And because it's a ping, it's a echo request, then the echo reply will come back. So when it's outbound from the PC, okay, PC2 and 3 lah, then you can see that destination IP address becomes the source of is from the source address of the broadcast message in the first place. Okay, then multicast, we know that it's one to some. Okay, host or interface that's part of the multicast group. In this case, it's ERGRP, so those members are the routers. Okay, but the way it works is that, as you can see, it's actually broadcasted. Okay, along by the router that's within that is connected to that particular network. So router one, okay, router one, not only it broadcasts not broadcast, it sends out multicast to router 2 and 3, but it also sends out to switch, and switch will broadcast it to all the hosts in the network. But the host sees that it is an ERGRP packet and just dropped it. That's why we see the X. Okay, so the takeaway is the traffic does not just go to simply go to those members. It also goes to other, which is not members, but the ones that are not members are not going to respond. They're just going to look at the destination, and it's not there. Then they know it's a multicast, and basically they're not part of the group because they're hosts, they're not routers, and then just drop it. Right? That's what we observe lah. Okay.
Okay.
Any other questions? Farah? Any question from you?
No question.
No question, huh? Noel also? If not, then we move on to the next exercise. So I'm going to present again. Okay, this next one is where we are going to learn about commands, how to configure IPv6 address. Okay, so far we've learned how to configure IP address, IPv4 address. Okay, for the IPv4 address, we simply type just IP lah. But IPv6, as you will see, that we actually going to type IPv6. But here we're going to learn to configure, I think, three types of devices. So let me just go to here. All right. So we're going to configure IP address on routers. Okay. On routers, what we are configuring the address is on the router interface. Okay. The router interface. And then the NIC on the server. Okay. And then NIC on the clients. So clients here basically are just desktop PCs or laptops, things like that, right? And the address are all already provided here. Okay, so for clients, okay, and servers, if they're part of the same network, the thing is, we also need to configure default gateway. This default gateway is the interface on the router that is the default router or default gateway. Okay, so for the router itself, of course, there's no gateway for routers because router is the gateway. But for the servers and clients, we need to also set, apart from the IP version 6 address, but also the default gateway address. Okay, so that's what we're going to do. Now, just follow the address given by this table, right? This table, and since we only covered IP version 4 in the theory, in next week, we'll try to speed up a bit and then cover the IP version 6 address format and also IP version 6 type of addresses. Just like IP version 4, you have the private, global, look back, test, and also automatically assign IP address, right, for host. IP version 6 also will have the same similar types of IP version address. Here, okay, if you're not sure, oh, what's this address, what does the address, never mind. Just take it as the address, and then the focus here is how do we configure, if we are given these addresses, how do we configure them onto the NICs and also the interface on the routers. Okay, we focus on that instead. The commands, yeah, in the especially at the router part, the iOS commands. Okay, right, and later on in the theory part, in the coming week, then we will see what's the difference between this address and that address, and what does it mean, right? Okay, so let's have a look at part 1 first. Okay, so router forwards packets along between networks. Okay, so in order, because by default router forwards IP version 4, normally we configure a router to forward IP version 4 packets. So what about if we also want to forward IP version 6 addresses? Because if we just configure those addresses, but we didn't set that the router need to forward those packets, the router won't forward. So step 1 is to enable, okay, the routing, okay, especially for IP version 6, okay, packets. So you go to router 1, okay, and then you see the command line interface. Just go inside and press return. Here we don't bother about all the basic configuration. Okay, we just want to focus on the new commands. But please take note that during SBA, later on you'll see in the course planner, you will the question might ask you to do all this, some of this basic configuration. So just practice, time to time practice on that. But here we don't bother with that. So we want to go privilege mode, so that enable. Okay. Inside here, we want to config terminal. Config T is the shortest we can do for configure terminal. So config T, we go inside config. So now we can do configuration. So in order, just follow the step, IP version 6, unicast routing. Okay, that means unicast is 1-to-1, right? Okay, so we want to enable the IP version 6 unicast routing. Okay, press enter, and that will be enabled. Okay, now we need to configure each of the interface on this router 1. So we start with how many interfaces do we have? You can see here 1, 2, 3. Okay, so we have 3. So as you can see in our configuration part 1, we have gigabit Ethernet 00, gigabit Ethernet 01, and serial 000. All 3 interfaces needs to be configured. Okay, so step 2, you can see the command. Step 3 and 4, no command already, but it's the same command. So you have to refer back to your table up there. Okay, you have to refer back to this table to find out what address to put for that particular interface. So you can see router 1, there's the gigabit 00, gigabit 01, serial 000, and respective addresses, okay, for that. Okay, so you have to configure two address. One is the global address and one is the link local address. Okay, so you can see for router one. Okay, now later on during the theory in the lecture in next week, we will discuss why we need two. Right, when we look at the different types of IPv6 address. For now, just know that you have to configure both, right? The first address and the second address, right? So this one, as you can see, is a link local, so it's link local type address. So if you want to read ahead to prepare for next week, also can, no problem. Maybe during the weekend, you can do that. So you can see this gigabit interface also has this two address. This also serial also have this two address. So you configure them, right? So I'm going to do the gigabit 00, and you guys will do the rest, yeah. So okay, so in order to configure the interface, I need to go inside the interface to to actually identify that interface. That interface is the one I'm configuring the IP address first. So you can see very clearly config, but here is config interface. So how do I go into that level? So just type the interface you're interested in. Interface, okay. You can type gigabit Ethernet 0/0, the full one, like this, gigabit Ethernet. Mind the typo, 0/0. But you can also do a short form. G for gigabit, S for serial. So I'm just going to do the short form 0/0. So when I press enter, I'm inside the configuration for that interface G00. Okay. Now I can do configuration. So the configuration I want to do is to assign the IP version 6 address for this interface. So I type IP version 6. If it's IP version 4, you just type IP address, the IP address and and that's it, right? And also the subnet mask. Okay, for IP address, you need to put in the subnet mask. Whereas IP version 6, you don't have to put the older type subnet mask. Because you put in prefix. Remember prefix? Prefix actually is to indicate the subnet mask, right? Prefix means the network portion. It's the same with IPv6. There's network and host portion. So the prefix indicate how many bits belong to network portion. That means then we can tell, we can build our subnet mask, right? So in IP version 4, we just type IP address, the IP address itself, and we have to physically type in the dotted decimal subnet mask address. But for IP version 6, we just use the slash prefix. Okay, so let's type that IP address, and I'll just follow what is given. DB@111/64. Okay, what if you make a mistake? Let's say I press enter. Oh no, I make a typo. Type the entire thing starting with no. Okay, that will remove that configuration. So now IP version 6 address whatever your typo is. So just put no in front, it will remove that configuration. So okay, IP version 6, the next address is the link local address, FE@01 link local. Okay, now very important. What is the mantra that I always mention to you guys? Every time you configure an address, whether the interface is up or down, just to be sure, that is up, so type no shutdown. Whether it's IPv6 you're setting or IPv4, just after you configure an interface, bring it up. Type no shutdown. Right? So, and then when you type that and actually change set to up, okay, that means it was down previously, it go up. But if it's up and you type no shutdown, doesn't matter. Okay, just it will still be up. So basically just making sure, right? Making sure. So right, so we've done the gigabit interface, gigabit Ethernet interface 00. So now I let you to do the other two, gigabit Ethernet 01 and serial 001, and just follow the address given here up here. All right, is that okay? Is that okay with you guys? Can do that, huh? Can do the rest, huh? The step 4 and 5. Sorry, step 3 and 4. Okay, I'll let you do that one, huh?
Okay.
All right, thanks for it. Okay,
Oh,
so after,
we do
yeah,
3, 4, 5.
sorry, 3, 4. 5 also, but 5 is just to verify. That means after you enter your addressing, you want to see whether did you make any typo, did it work or whatever. Just to confirm, without going into each of the interface again, make sure when you're here, after you finish and it's up, no shutdown up, to return back to the normal configuration, press exit, type exit, press enter, and then you have to type the next interface that you want to get in. Interface, let's say it's G01, right? You type, and then you go in. Remember, if you keep on, if you don't exit and go in a different interface, you're basically changing the current interface. Okay, you exit first. Okay, you exit first from that interface G00, go back to config, and then type the other interface that you want to configure, interface 01. After you finish with interface 01, exit again, and then type interface serial S000. All right. Okay, so after you complete that, exit again to config, and what you want to do is to verify and exit all the way up to the privilege mode there. And type this command, show IP version 6 interface brief. This is the same command as for IP version 4, but it's just now we add IP version 6 instead of IP. So that will show you the interface brief in a brief listing. Okay, it shows the interface whether it's up or down, and also shows you the address that you have specified. Okay, so if you make mistake, again, go back into that interface, type no in front of the command that you entered, and then re-enter the correct address. Okay, so remember in iOS, no in front of the original command will actually disable that or remove that entry. Okay. Okay, so D, save the router configuration to environment is copy running config, startup, config. That's all. Okay. Right. Now, once you do for the router, when we close this first, we want to do for the server. So servers, we have two, accounting and CAD. My accounting doesn't have a cable. Hang on. Is it the same with you guys? There's no cable? Are we supposed to put cable in? Oh, no need. Let me just, no cable, huh?
Yeah,
Yeah.
No cable. Okay, never mind. We'll see whether we need to do anything about it. Okay, so configure IP version 6 address on the accounting server. So basically just click on it. All right, go to desktop. We're already in desktop. Just click IP configuration, the first option. All right, so of course, the interface will be different on the real server, depending whether it's a Linux server or a Windows server, right? So this is just a, a generic kind of way for you to set the address. Okay, just remember, on a real server, it depends on the operating system. Whether it's Linux, whether it's Windows, it has its own interface for you to change the IP configuration. In Linux, I think on the server, you need to go into the etc directory and change one of the configuration files, something like that. Okay. On the desktop Linux, where you have the desktop environment, the GUI, then depending on your desktop environment, again, whether you are running GNOME, KDE, LXE, or whatever, what kind of desktop GUI that you have running, then maybe the GUI for changing the setting the IP address, it will be different. So just to let you know, in the real world, it depends on the OS. Okay, depend on the OS. What's the interface look like? Whether it's command line or it's GUI, and if GUI, what kind of desktop windowing system they have for the OS. Especially with Linux, there's so many variety. It depends on the distribution. If you go for Red Hat, it's different. You go for Debian, it's different. And any distribution based on Debian also different, depending on whether it's what kind of desktop environment you have. Whether GNOME, KDE, one of those elementary OS kind of thing. There's a lot of distribution, so different types. So, but the two most common is the KDE and GNOME, right? So back to here, right? So we want to select the IP version 6. Okay, so type in the address and its prefix inside here. The link local already given, so don't need to touch that one. Okay, you need to touch that one, and don't forget to put default gateway, or else the traffic cannot go outside. So we can see here accounting. Here is the IP address in prefix. So that means the prefix you put here, 64. Let me just do it. Go here. For this one, I do this one for you. So copy that. You can copy paste, or you can type in. No problem. Prefix there. Default gateway is FE at 0, 1. Okay. So and you've configured it. Okay, static IP version 6. Don't worry about IP version 4. Certain network, certain organization, they might have fully transitioned to IP version 6, and within their own network, they are very confident all of their devices, hardware, host, whatever, are all IP version 6. So they might fully utilize your IP version 6. It's only when you are communicating on the internet, you're not too sure which of the services on the internet servers are fully IP version 6 or still rely on IP version 4. Okay, but what you can control is your own organization. All right. So once you've done that, that's it. Complete already for the server. Right. Okay. So then you can close. Okay. Close that. Now it says configure CAD with the address. It's very similar to accounting, but now using the CAD addresses. Okay, so I let you do that on your own. Okay, so you can practice. Then after that, we will do the clients. Clients basically are this is a client's, here we are talking about client server environment. So we have accounting server, we have the CAD server, and the other host becomes the client of these two servers. So that's why we call it client. So we go to the first one to configure billing. So let's go to this laptop and go desktop, go IP configuration as well. Okay, and then same thing, you put it in here, IP version 6 address. Okay, I'm gonna depend on here, billing. right? Put the prefix in 64 and skip the link local. If there's no link local, it's okay. So FE F0, this is the gateway address. Yeah. Right. Done, yeah? Okay, so let's see what else it needs for the clients. Okay, billing, yeah, yep. Okay, that's it. And then do the same for sales. And then we go to the other network. How do I know it's another network? Because you see here, it's separated by a router. Router connects network together. So this is one network. On the left, this is one network. And this is a different network. All right. So if you finish everything, yeah, configuring everything, all should light up green, especially this part, this interface here, router one interface. Here's still red, right? Okay. The link light still red because we haven't. I did not configure the interface. This interface, the G01. If you configure, then the link lights will turn to green. Okay, so that will indicate to you, right? So you go to the other network and do the same for the. Let me see. Engineering. Give it address and for design as well. Okay, then go to sales. After you finish, this is verifying already. Once you finish step 2, you configure for engineering and design on this other network, then you're done, right? Because you already set for the accounting and CAD earlier on. And then part 4, we want to test and verify network connectivity. Open the server web page from clients. So clients, any clients will do. So click sales. So we're going to start from sales, right? Since we closed it already just now, no need to close again. So go to web browser. Just go a bit to the right. You can see the web browser here. Click on it and type the address 2001 into the URL. I'm pretty sure this we have to type the IP address because we don't have DNS service in this network. So and then click go. Accounting website should appear. Right? Enter the other address in the URL box, and the other web server website will appear. The CAT website will appear. Now I just want to address the elephant in the room. There is no connection between the switch and the accounting. So the fact here it says the accounting website should appear. Do you think so? Can I ask you guys? Do you think it will appear or not? Even though you configured all the addresses.
No.
No, right? So what should you do in order for the accounting server to be connected to the network?
Connect
Yeah, well,
with the
connect. Yeah, all right.
media.
Farah, which cable should we use to connect the switch to accounting?
I think the straight cable.
Yeah, straight through.
Yeah,
Yeah,
straight through.
that's it. Yeah. So if you want it to appear, that means you have to do that first. You have to connect, right? Connect to the accounting interface. Okay, network interface card on accounting with the switch port. The switch, since the switch we don't, in this exercise, we don't deal with the switch. That means you can connect to any port on the switch, right? All right, so and finally, because if you have set correctly the serial line interface here on the router one, these two link lights up here connecting to your ISP should turn green, and then you want to test that. Pick on any client, whether design or sales, right? Maybe both lah, sales and design, something like that, so that you can see whether this network connectivity to the ISP and this network connectivity to ISP is okay or not. We want to verify the connectivity. So what you want to do is ping on that client, whether sales or design, billing or engineering, you want to ping from them. You want to open a command prompt and do this ping this address. As you can see, that address is indicated here is the interface of the ISP network, right? It may be the ISP has its own inside here. Maybe there's a router connecting to router one. So that router's interface address is this given here as a label. So it's also given here. So ping that, right? And from sales, billings, design, engineering, or even from the CAD and accounting, okay? And to verify that yes, all the servers and clients within two separate networks can actually access to ISP, right? Or any question?
No.
No, huh? Okay. So
No.
okay, so I let you guys to configure, all right? Kelvin, no question?
No.
Okay. All right. So continue. Do the configuration for all of the servers, the interface on the router one, and the clients. Okay. Any questions? Let me know. I'm monitoring. And later, about 20-25 minutes like that, I'll check with you guys, see whether you success or not. If you success already, you can also tell me, right? If you connected successfully earlier. All right.
Also, what is the safe router configuration?
Sorry, I didn't. Okay, it's similar to the command we use for the switch. So coffee running config, startup config. Remember that command in switch? Basically, a lot of commands for the switches is the same for the router as well, especially with Cisco switches and routers. Is that okay? Does that answer your question?
Uh, how do you write that?
All right. So let me just
Config.
right at the enable at the privilege mode, just type copy running config. Running config, ah.
Only that.
Yeah, running config, select config. Running config, I'm not sure is running config got dash or not. Let me just double check. Running config. Okay, running config. I think running config is laptop config. Let me just, I'm not sure whether it's underscore or dash. Let me just double check.
Dash.
Is it dash?
Oh yeah, dash.
Something like that. If it's dash, yeah, this is a dash. Thank you. Okay. So it's the same command and we have at the switch. Another matter, you guys can access the netacap chapter exam. Did you try? Any of you try?
Not yet.
Not yet, So maybe during the weekend when you're doing revision, you want to do the chapter exam. Let me know, if you. I'm pretty sure you can access because I already opened up the access earlier on. But let me know if you've encountered any difficulties to access it. I think each chapter exam you can redo up to 10 times, right? If you do more than that, if you need more than that, then let me know, okay? But I think once or twice, okay, it should be sufficient for revision. It should let you, by doing that, it should let you know which topic that you're not sure about because you got the wrong answer or you can't answer. Then that will allow you to go to read more on that particular topic. All right. Okay. Make use of the NetAcad online for your revision.
Sir.
Okay, that means you can access,
Is it
right?
this one?
Yeah.
Oh.
You click test. If you click tech assessment, I'm not sure. I think you can stop halfway, but I think it's better you find a time, maybe 15, 20 minutes, something like that. So you can, no interruption, you can do uh, the whole, I think it's 20 questions or 20 plus questions per chapter, right? Then you can focus and then try to answer. And then at the end of it, the system is going to tell you how many marks you get, what you get wrong. So from there you can tell which topic you're not too sure about, and then it can guide you in your revision. Right?
Okay.
Okay. Hello.
Yeah.
Yeah. So how is it?
I finished.
How's it going? Kelvin, you finished.
Yeah.
So how you managed to ping the ISP?
Yeah.
Yeah. Okay. But for you, Farah,
I'm halfway.
halfway. All right. So far okay lah, Farah. No problem. Just
So
follow
far okay
through
lah.
the. Yeah. Okay, Noel, you
Yeah. Finish.
finish also. And able to ping successfully lah.
Yeah.
Right. You can also access the web server.
Yeah.
Yeah.
Yeah. Okay. All right, Farah. I think you should just need some time. All right. I think you just continue, and I think no problem lah. All right. So, any questions before we end today's session?
No.
No question. Calvin and Noel?
No.
No, huh? All right. Okay. In that case, thank you very much for today. I think we end our sessions now.
Okay, sir.
Okay.
Okay.
All
Thank you,
right.
sir.
All right.